your timber and getting an annual crop of wheat at the same time. Here's an example from China, where timber species like Paulownia are intercropped with wheat on millions of hectares. And because the wheat is grown during the cool season, when the Paulownia trees are deciduous and have no leaves, there's very minimal interaction or shading of the trees to the cropping system, so that your yields of wheat are almost as high as they are with monoculture, while you're getting the additional value of an important timber tree crop as well. In the tropics, there are so many examples of intercropping trees with crops. One of the most interesting ones here in Africa is intercropping trees with conservation farming systems based on zero-tillage maize. And this one features an acacia tree called Phytherbia that is dormant during the wet season and has high nitrogen supply to the crop during the crop season, and then leafs out, as you see here, at the end of the growing season. Likewise, these systems with hybrid maize and Phytherbia trees look just like forests in places like Tanzania, where those intercrops are being practiced by farmers. Perhaps the most dramatic case of the intercropping of trees with field crops is in the Sahelian or the dryland zone of Africa, where millions upon millions of hectares of farmland is now covered with these Phytherbia trees that were naturally regenerated in sorghum and millet fields. And indeed, if you fly over these areas, you see these vast, in this case, 5 million hectares of contiguous regeneration of these acacia trees in sorghum and millet production systems. Well, indeed, we need more thoughtful approaches to the types of equipment that can establish and particularly to prune the trees that we have in these cropping systems in order to minimize and trade-offs between the trees and crops and optimize the returns on the whole production system. I would like now to give the floor to a man who has devoted his life to developing models for tree crop interactions that are specifically suited to the U.S. Corn Belt. Mark Shepard runs a 106-acre farm in southern Wisconsin that he converted from row crop grain enterprises into a commercial-scale, perennial annual agricultural ecosystem. And he started from the perspective of combining ecological theory with hard-nosed economics. And in the process, he's created a profitable farm based on the concept of developing a farmscape that mimics the original oak savanna ecology of southern Wisconsin. In Mark's new book, Restoration Agriculture, he has made the effort to show in detail how these systems work and how others can do it too. The really great opportunity here is that this can be a system further refined and replicated. And it's gratifying that serious research is now underway to look at how these systems can be the basis for a major transformation of Corn Belt agriculture. We need to match that agronomic or agroforestry research with more intensive work on special purpose machinery to further enhance the efficiency of farmers to manage these systems. Now, Mark has had to mostly fashion his own equipment in order to manage his alley cropping systems. But Mark, we look forward to your thoughts and proposals on how the engineering profession can assist in developing equipment that can assist farmers in increasing numbers like you who are creating alley cropping systems in the temperate zone. With this dedication of the engineering, creativity, and innovation, we hope that we can, in fact, instill a new way of looking at the management of tree crop systems here in the United States as well as across the world. Thank you very much. Mark, you have the floor.